Now move further, which is what is tampering. Okay, so fourth one is tampering. This is also the part of the heat treatment, and but this is a category of kind of after hardness. Okay, we do the same material. Let me read the process first. So for what is the purpose? To reduce the brittleness and improve toughness in hardened steel. So whatever the steel that we got after hardening in this process of what we have done in three. Okay, so here we are getting the high hardness, but at the same time we are getting the high brittleness, low toughness. Okay, so for that matter, we do the tempering so that we can reduce the brittleness, improve the toughness. Okay, in the same hardness. So once we have done with hardening, quenching, then the same material, because they are having the very high brittleness, having the low toughness, though they are having the high wear resistance. For that, and we cannot actually use because the higher brittle material is not going to use as a part of component, right? So that's why we must need to make that material as a little bit ductile and having less brittleness. Okay, for that reason, we have another process which is known as tempering. How we do that? They repeat the quenching steel. I mean, whatever we have done in quenching in the hardening. Okay, we have to do the same thing again, repeat steel to the temperature below the lower critical temperature. Here, what we are doing, we just need to. I mean, once we have done till here, we got the material after quenching. Now we need to heat that material. Okay, but below the lower critical temperature, not higher. Okay, but in this process, we have what we were doing. We were doing the higher critical temperature or upper critical temperature. But here in tempering, we will raise the temperature below the lower critical temperature, typically around 150 to 650 100 degrees C, right? This is the temperature. Hold at this temperature for other specific time. Why? For the reason their internal structure get change or phase change will occurs. Okay. Cool in air or oil the same the way that we have done earlier. Now, okay, same process, same thing, but the raising the temperature is a different. In before we were raising the temperature, upper critical above the upper critical temperature, right? Now we are having the lower than the below the lower critical temperature. Okay, so we are just you can say we are not hitting that much as we've done in hardening. Okay, and then we are allowing them to cool down in the same process, either high low temperature and high speed air, and there in oil or water. Okay, but you must be aware, you must have to keep in mind that after hardening we go for the tempering. Okay, for the same material we are just doing the two process, first by hardening, then we go for tempering. Okay, so, repeating the quenching steel to the temperature below the lower critical temperature, typically around 150 to 650 degrees C. Okay, hold at this temperature for the specific time, then cool it in air or oil or water. What are the microstructures that we get here? The tempered martensite is a mixture of the ferrite and cementite. That's kind of the microstructure that we get here. Okay, if you all have a if anybody or all of you having a difficulties about knowing what is mutton side, what is mixed, yeah, I hope that in unit second. So what are the applications they used for the tools, springs and structure components? These are the main process, so you can at least understand here what the thing is going on first. I mean, how we can go to the at what temperature, and why we and what matter, what way that we are approaching to let them cool down. Okay, so that is the main things that you can understand at least.